So now let's work on an ancestor tree, taking a function that returns not just a Boolean or a string, but returns an entire other tree. So we'll repeat the example of changeName. By the way, I suggest before doing this, go and take some of the function we wrote in the Racket version, like contains. We already did size, now do contains, maybe do the one that returns a list of names. Rewrite those in Java. You can use Java util list if you like. And see if you can get those, and those again should follow the template and are very much like the Racket version and the version we just wrote of size. Okay, so we want to go and I want to write the changeName method. Okay, so the first thing to worry about is, Java's going to make us take a little moment to get here. Okay, so the first thing we'll do is write some test case. I have the function changeName. I'll start with some easy examples. If I take the empty family tree, the unknown person, the unknown ancestor tree, and change Jackie to Jack in there, I should get back something equal to unknown. What dot equals are we calling? Oh, the built-in dot equals works the same as equal, and we want to we want to say, hey, two ancestor trees are identical if they're both unknowns, or if one is a child and the other a child, and they have the same name and eye color and birth year, and same mother's family tree and same father's family tree recursively. So equals is going to follow the template for writing a method, but we need to write equals just to write our test cases for a function that returns a family tree. So, okay. And now we have to do a little bit of I have a separate video on more of this, but again, how do we write dot equals for unknowns? You can pause the video if you know how to do all this. If you're sure you know how to do it, you can skip ahead to the time index listed down below in the comments there. But otherwise, go ahead and write a dot equals and see if you get all the nuances that we'll talk about as soon as you unpause. Okay, so let's go and write equals. Where should we put equals? Well, we're going to override it. So yeah, I guess we should go ahead and put it in ancestor tree and unknown and child. Ancestor tree is abstract. Actually, although we're overriding the equals way, way up in unknown, so I think we can get a bit by. I don't think it's any sort of bad design principle. I think just override it inside unknown, override it again inside equals, perhaps. Java can't give us warnings if we skip it, no matter whether we put it abstract in maybe if I put it abstract in ancestor tree, I'll get a warning. I'll have to try that in a moment. Okay. Oh, I'm in the middle of writing some test cases there, so let's close that. Okay. Just gonna make sure that. Okay. Go to unknown here. How do we write equals? Now you're like, duh, this is super easy. So I'm gonna go ahead and put an override. What is the signature for equals again? The first non-trivial part. Public Boolean equals. We're inside class unknown, so I'll go ahead and write, hey, I'm unknown this coming in. What is the type of the other argument? Could be any object. So not just another unknown, not just another AncTree. I want to, hey, is this unknown family tree equal to the string whoopsie daisy? Better return false on that. So be able to take in any other object. So that's the first kind of gotcha in writing this in Java. And how, again, this is almost sort of a rote thing to sort of memorize. How do you do this? Gosh, first of all, that could be null. So if that equal null, return false. Else if this, so here, and again, we don't need this, but it'll be a shortcut. If this equal that, return true. Again, this is a hot path, meaning we'll put it in because it's relatively common, and this will get us past a bunch of other code that would slow us down. Otherwise, it's an optimization. You can take it out and be equally correct. Else if this dot get class not equal to that dot get class. Okay. Okay. If they are not equal, we return false. Else, and now we're ready to compare our fields. Now in this case, unknown doesn't have any fields, right? So else return true, off on the bottom of the screen there. Okay, that is overriding equals for the unknown class. Okay, so how do we go ahead and override unknown for a child object? Actually, I put it up over here. Same boilerplate code. Check for null. Maybe your hot path if you want it. Check the same class. If they're not the same class, then we can start comparing fields. So you can look at this dot name and that dot name. Except that, gosh, the computer will say, Java compiler will say that is a capital O object. I don't know that it has a dot name field. We just checked for that. That's what the previous get class line is double checking. Compiler won't optimize that for us. So I'll make my own another reference, the same as that, just doing a cast and give it a new name. I suppose I could reassign to that. I don't like reassigning to my parameter at all, even for a cast that's doing nothing there. And now I can go ahead and say, hey, that dot name called dot equals for strings, called equal for ints, called dot equals. And then that dot ma dot equals this dot ma. Hey, that's our recursive call by the template. Our template suggested pulling out these 5 fields, and then we just want to call the equals on all of them, even when it's the recursive equals. Okay, so, or at least the version that goes back up to an ancestor tree. Okay, so that's a little side note on, did you correctly override equals? Oh, wait a minute. When you override equals, you should always also override hash code. If you didn't override hash code, bang. Man, Java's just kicking us when we're down, aren't we? Okay, so, well, regardless, I have some separate videos on, I'll put it in the comments about how to write hash code. We've talked about that in class before already. Okay, now let's get back to our test cases for the ancestor tree. Go up to here. And now I can, go ahead, now that I have dot equals written, then I can go ahead and try that. Assert, how about Jackie dot change name Jackie to Jack equals, and now, gosh, new child of Jack, comma, what is Jackie's birth year? 1917 Brown. Okay. There we are. Okay. And so we can go ahead and spell this out just like we did in Java. If you want to create this earlier and give it a name, that's fine. But, okay, and what else do we want to do? I'm not sure how to indent this. The indentation is even worse than bracket, isn't it? Okay, what else? How about if I had a tree that didn't involve, or how about names that don't involve names in the tree? Zach to Zacko. In that case, we should get back new child of Jackie, 1917 Brown, Unk. I could just say here Jackie, right? Jackie is dot equals to this thing. Okay. So, okay. And I can make bigger and bigger trees and so on. Now let's go right to, I'm not going to go through the other test cases. We wrote those in Racket. You can translate those directly. Let's now finally finish up real quick and look at the code that follows from the template, the code for change name. Okay, first I'm going to go ahead here and copy, paste, change name returns an AncTree, and I'm going to get that. This is the abstract version. Okay, get rid of that now. Finally get stuff to compile. Oh, okay, well, we'll get to that. Okay, so change name is abstract up here. Let's go into unknown and do change name. Can take our thing. We should probably add this at override, the version that is for, I should put that on eat.equals too. Did I do that? I forget. Change name takes in a this and a string target and a string replacement. I need to put those names in my parameter, don't I? Okay. How does changeName work for an unknown ancestor tree? Hey, return the unknown ancestor tree. I can use this. Many different things I could put here, but okay. Great. Let me get this signature fully done. Let me make sure that I went up in changeName here and use the right signature. Oh, except it's not void, is it? Okay, whew. That's the correct signature. Getting better, going back to unknown. And eventually I'll get my Java all correctly accented here. And then finally, let's go to the child family tree and put in the right signature, copy and paste the template. Okay, and how does changeName work? We are going to use all these different things. We're going to go ahead and use new child of, and I'll get to, well, I want to do the if statement on this, but in the meantime, I have You may have seen me write my commas like this before. Okay. Except it's changeName. And we go ahead and pass it target and replacement. REPL. Target REPL. And what was that one other thing we want to do? If this.name.equals target, then use the replacement. Otherwise, use this.name. Okay. And now I think we have that. And I have to go and figure out, I have some missing thing here. But that's how our code goes. Look at that. Is it exactly the same as the racket code that we wrote? Okay, and I just have to get all my missing brackets, extra things here. Unknown is, so you can't see the error message, but it says unknown is not abstract and does not override changeName. Didn't I put changeName down here? String. The right ancestor tree. Look at that full thing. Does not override the version in unknown. I'm not clear why it says it doesn't override the version in unknown. Okay, well, I'll figure that out and make sure to publish code, but yeah, somehow I get more syntax errors when I use Java. Brain too small. Okay, yeah, so that's the point of how we handle union types in Java, including the design recipe fully in every single step. So awesome. We'll come back. I'll maybe make an optional lecture for how to do the same thing, not in Scala, but in other languages. That's not in Java, but in another language that compiles to the JVM. I'll do this in Scala, and we'll see our exact same Java code, except smaller. So, but that'll be sort of an optional lecture. You're good to go with the homework at this point.